I'm now going to discuss set language and notation. Now, a set is just another word for a list. And items in a set are called elements. So how do we describe sets? Now, a set can be described by listing all of its elements. And I'll look at an example in a minute. So a set can be described by listing all of its elements. Okay. For example, set S can be described by listing its elements. And suppose its elements are 1, 3, 5, 7, and 9. That is just how we describe it. And I can write this in words, whatever is meant by this. So this means S is the set whose elements are so this is how we describe a set. Okay, we use this notation here. The 5 elements of the set are separated by commas. So you have a comma here, you have a comma here, you have a comma there, you have a comma there, and then they are enclosed between curly brackets. So you have a curly bracket here and the curly bracket on the left. A set can also be described by writing a description of its elements between the curly brackets. So a set can also be described by writing So what you're saying here is a set can also be described by writing a description of its elements between curly brackets. So, for example, the set S in the previous page, the set S can also be written as S is equal to, you have a curly bracket and you just write a description of what those elements are. Odd whole numbers that are less than 10. And then you close the curly bracket. So what this means is S is the set of odd whole numbers less than 10. So different ways on how you can describe a set. We looked at one way is you can use the curly bracket and basically list your elements using commas. Another way to do it is by describing it. So you have the curly bracket and basically you describe what it is. Odd whole numbers less than 10. And what that means is the set of odd whole numbers that are less than 10. I'll look at the next thing, which is equal sets. Now, two sets are called equal or are said to be equal if they have exactly the same elements. So two sets okay. For example, so suppose you have a set 1, 3, 5, 7, and 9. This will be equal to 3, 9, 7, 5, and 1 because they're exactly the same elements. The order doesn't matter. They're exactly the same elements. But of course order differently, and the order doesn't matter. So these two sets are equal. This will also be equal to 5, 9, 1, 3, and 7. And these are exactly the same elements and of course order differently. So the order doesn't matter. These two are equal. Next, I'm going to look at these symbols. The symbols member of and not member of. Now, I'll use an example to explain this. So suppose set A is given by 3, 4, 5, and 6. Then we can say that 3 is a member of set A. So basically, we read this as 3 is an element or a member of an element of set A. We can also, because of course this makes sense because 3 is definitely an element in set A. We can also see that 8 is not an element of set A. So we read this as 8 is not an element of set A. So this is very important. So this symbol here means an element of, and this symbol here means whatever that is, whatever we're referring to is not an element of whatever set that you are referring to. So I'll look at something else. The empty set. We use certain symbols to represent the empty set. So the symbol, so this symbol here, or just the empty curly brackets, those are used to represent empty sets. So this represents so an empty set is basically a set that has no elements at all, and we use these symbols here to represent them. Next, I'm going to look at universal set. Now, a universal set is a set that contains all of the elements in all of the sets being considered. So it is a set that contains all of the elements, and I'll use an example to explain this in a minute. So it is a set that contains all of the elements in all of the sets being considered. Okay. For example, suppose, so I'll say, suppose A is 1, 2, 3. Suppose set A is what contains elements 1, 2, 3, and B, set B contains element 2, 3, and 4, and set C contains elements 3, 5, and 7. Then then the universal set. The symbol used for universal set is an E. So it's something like that. The universal set will be represented by, now remember what is said what a universal set is. It's a set that contains all of the elements in all of the sets being considered. And here we're considering set A, B, and C. So the universal set will contain all these guys. So it will contain 1, 2, 3, 4, 5, and 7. Now, I just said that the universal set is usually given the symbol that looks like an E. So the universal set is usually given the symbol that looks like an E.